So here in today's video we are going to see the properties of definite integrals. So what is a definite integral? Actually here it's nothing but about the limit. You have a upper limit and a lower limit that we have seen in the last exercise itself actually here. So we have few properties relating to this definite integrals here. The first property is nothing but integral over a to b f of x dx is equal to integral over a to b f of t dt. So what is the meaning of it actually here? Suppose if I have integral over x squared dx over the limit 1 to 2. So when you integrate it, what will I have? It's x cube by 3 over the limit 1 to 2 you have here. It's 8 by 3 minus 1 by 3 you have here. That's nothing but equal to 7 by 3. This is what you get here. Similarly, if this x is replaced by t here, if it's t squared, and if you have the same limit dt, what will I have here? It's nothing but t cube divided by 3 over the limit 1 to 2. So what will I have again? It will be nothing but 8 by 3 minus 1 by 3 you get. That's nothing but equal to 7 by 3. This is what you have here. Is it clear? So whatever it is, even if the variable changes in this case, the answer will be nothing but the same. That's what I mean by saying integral over a to b f of x dx is equal to integral over a to b f of t dt. Now here the second one. So if the order of the limit changes, that is from a to b, if it changes from b to a, then the answer is equal to minus sign of that. So integral over a to b f of x dx is equal to minus integral of b to a f of x dx. This is what you have here. Okay. Now the third one, integral over a to b f of x dx is equal to integral over. So here if you see, I have a limit like this, a to b, and in between I have a break like this. So I can split it as a to c and c to b. That is nothing but equal to a to b here. Okay. So I can write it as integral over a to c f of x dx plus integral over c to b f of x dx. This is what you have here. Now the fourth one, what's the fourth one? You get integral over a to b f of x dx is equal to, okay, so here in this case we call it as a shifting property. In this case it's nothing but equal to integral over a to b f of the sum of the upper limit and the lower limit minus this one here x. So f of a plus b minus x. This is the limit you have here. Okay, we'll be using these properties here in our problem, so that's why I'm explaining the properties in this case. Now the fifth one, what is it? Integral over 0 to a f of x dx is equal to integral over 0 to a, your x is replaced by the upper limit minus x. So what's the upper limit minus x? What will I get here? It's nothing but a minus x dx. So you have it as f of a minus x dx, integral over 0 to a f of a minus x dx. This is what you have here. Now the sixth one is what? Integral over 0 to 2a f of x. So if it is 0 to twice the limit, I can write it as twice of integral over 0 to a f of x dx. This is what you have here. Okay. Now the seventh one, integral over minus a to a f of x dx, that is equal to 0 when f of x is said to be an odd function. So what is meant by an odd function? Your f of minus x is equal to minus f of x. That only we call it as an odd function. So when do I say that a function is said to be odd? Suppose if I have it as f of x is equal to x cube, what is your f of minus x equal to? Your f of minus x is equal to minus x the whole cube you get here, which is equal to minus x cube. So you have it as f of x is equal to, or f of minus x is equal to minus f of x. This only we call it as an odd function. Okay. So here it's an odd function. Then the lower limit is minus a to a. We say that it is equal to 0. Next is what? Integral over minus a to a f of x dx. So what is integral over minus a to a f of x dx? If it is said to be an even function. So what is an even function? If your f of minus x is equal to f of x. So what was that I have here? Suppose if I have f of x is equal to x squared, what is your f of minus x equal to here? Minus x is equal to minus x the whole square. That's nothing but equal to x squared. It's nothing but equal to f of x. This is what you have here. So I can say that minus a to a f of x dx is equal to twice of integral over 0 to a f of x dx. Then we say that your f of x is said to be an even function, then it is equal to 2 times integral over 0 to a f of x dx. Is it clear? Okay. So these are the properties. So I'll tell you what are all the properties. Mainly I'll be using it here. this property I'll be using, the fifth property will be using here, and I'll be using the third property also and the seventh property. Most often, it's not that I'll not be using the other properties, but most often I'll be using these three properties. Okay, so with these properties in mind, we'll go over to the exercise here. That's nothing but exercise 7.11. So what is your exercise 7.11? What will I get here? Exercise 7.11, I is equal to integral over 0 to pi by 2 cos squared x dx. Okay, so I is equal to, so keeping it as it is, it's not possible for me to integrate it. By using the trigonometric identity, of course I can integrate it, but I'm using the properties here. So what's the property I'm going to use here? Integral over 0 to a f of x dx is equal to integral over 0 to a f of a minus x. What property am I using here? Actually here it's nothing but property 5. This is the property I am using here. So I is equal to integral over 0 to pi by 2 cos squared of, what is that I have here? Your x is replaced by the upper limit minus x. What's the upper limit you have here? It's pi by 2. So how do I write it here? Cos squared of pi by 2 minus x. What is cos squared? What is cos of pi by 2 minus x? It's nothing but sine. So I can write it as sine squared x dx. But you would have studied the all silver teacups in your 11th standard by using that. Okay. So I mark this equation as 1. Got it? Now here, sorry, 2 here. This I mark it as 1. The question I mark it as 1 and this as 2. Now we'll add 1 and 2. So when I add 1 and 2, I, here also you have an I here. I plus I will give you what? 2I is equal to integral over 0 to pi by 2. Since both have the same limit, I can just add the integrands here. Sin squared x plus cos squared x dx is equal to integral over 0 to pi by 2. So here, what is sin square theta plus cos square theta? It's nothing but 1 into dx. What is integral of dx? It's nothing but x over the limit 0 to pi by 2, which is equal to the upper limit will give me what? Pi by 2 you get. So you get 2I is equal to pi by 2. So what's the value of I equal to here? I is nothing but equal to pi by 4. You understood? Yes. Second question, integral over 0 to pi by 2 root of sin x divided by root sin x plus root cos x dx. So what is your I equal to here? I is equal to integral over 0 to pi by 2. Of course, I'll just write the question again here. I've just given a name to this I here, and we mark it to be equal to 1. Okay. Now here again I'm going to use the same property. What's it? The property I'm going to use here? The fifth property, integral over 0 to a f of x dx is equal to integral over 0 to a, it's nothing but f of a minus x dx. This is what you get here. Okay, 0 to a f of x dx, which is equal to integral over 0 to a f of a minus x dx. This is what you have here. So how do I write in this case? Actually here you can write it as I is equal to integral over 0 to pi by 2 root of sine of the upper limit. What's the upper limit you get here? Pi by 2 minus x divided by square root of sine of the upper limit. What's the upper limit again you have here? Pi by 2 minus x plus square root of cos of, what will I get? Upper limit minus x. What's your upper limit again here? It's pi by 2 minus x dx. What is sine of pi by 2 minus x actually here? It's nothing but equal to cos x. Sine of pi by 2 minus theta is nothing but equal to cos. Similarly, divided by root of sine of pi by 2 minus x is what? Cos x, root cos x, plus root of cos of pi by 2 minus x. What is that equal to here? It's nothing but equal to sin x. This is what you have here. So whatever I have changed here by using this shifting property here, shift scale, I have just marked it as 2. So this is 1 and this is 2. So what's the next step I will do here? I will add 1 and 2 here, 1 plus 2. Got it? So 1 plus 2 is what actually here? I plus I. What is I plus I? It's equal to 2I you have here, which is equal to integral over 0 to pi by 2. Now again, as I told you, it has got the same limit here. So I can just add these two integrands here. So when I add the integrands, the denominator is the same. So I can just add the numerator here. It's root sin x plus root cos x divided by, it has got the same denominator. That's nothing but root cos x plus sin x. So what happens here? It gets cancelled. You're left with integral over 0 to pi by 2 dx, which is equal to x over the limit 0 to pi by 2. When you apply the upper limit, what will I get? It's nothing but equal to pi by 2. So what will I have? I is equal to pi by 4. This is what you get here. So I equal to pi by 4. You understood? Yes. So here again, before evaluating the integral, check if you can do it by substitution or if you can do it by any other method, and then if it's not possible, I'll be doing by using this property here. Okay, such thing. Now here the third question, again it's a similar one only. So it's integral over 0 to pi by 2 sine power 3 by 2 x divided by sine power 3 by 2 plus cos power 3 by 2 dx dx. Now if you look at this integral, it's not possible for me to do it by substitution actually. Whatever I substitute, I'm not going to get the numerator also. Substitution is not possible in this case. So just think which is the property I can use here by using the definite integral property. What is a definite integral property? Integral over 0 to a f of x dx is equal to integral over 0 to a, it's nothing but f of a minus x dx. This is the property we use here. So by using this property, I can write it as integral over 0 to pi by 2 sine power 3 by 2 into, it's nothing but pi by 2 minus x. Okay, so the upper limit, this one, of course, the question I have marked it as 1. So it is sine power 3 by 2 into pi by 2 minus x divided by sine power 3 by 2 of pi by 2 minus x plus cos power 3 by 2 of pi by 2 minus x dx. This is what you get here. So what is your sine power 3 by 2 of pi by 2 minus x? It's nothing but cos power 3 by 2 x you have here. Okay, it's integral over 0 to pi by 2, of course you have, divided by, what is sine of pi by 2? Sine of pi by 2 minus x is what? Cos. Sine of pi by 2 will be changed to cos here. So it's cos power 3 by 2 x plus, what is the next one you get here? Sine power 3 by 2 x dx. So I'll mark it as 2. Now what's the next step I'll do here? I'll have to add these both. When I add it, what will I get here? I plus I, because this is nothing but equal to I. So you will get it as 2I. So here it's 2I you get here, which is equal to integral over 0 to pi by 2. As I told you, if the limit is the same, I can just add both the integrands here. So I've written the first one, sine power 3 by 2 by x divided by cos power 3 by 2x plus sine power 3 by 2x plus cos power 3 by 2x divided by sine power 3 by 2x plus cos power 3 by 2x you have here. So this is equal to integral over 0 to pi by 2. I can just add the numerator there. So you will have it as sine power 3 by 2x plus cos power 3 by 2x divided by cos power 3 by 2x plus sine power 3 by 2x. What happens here actually? This gets cancelled. You are left with integral over 0 to pi by 2. It's nothing but dx. So when I integrate it, of course, don't forget this 2i here. This is the place where we commonly make mistake here. So 2i is equal to, here in this case, it's x over the limit 0 to pi by 2. When you apply the upper limit, what will I get? It's nothing but pi by 2. So what's our I equal to actually here? I is equal to pi by 4. This is what you have here. Got it? Yes. Now we'll go over the next one here. So what is your next one you get here? Fifth one. Fifth one is nothing but integral over minus 5 to 5 mod of x plus 2 dx. So when you have always mod of x plus 2 dx, actually you must not integrate it keeping it as it is, because if you see there it is mod of. So what I'll have to do here is I'll have to eliminate this mod. How can I eliminate this mod? You know what is the absolute value of x, a general thing. I've told you in the under differentiation, under the first exercise itself, I've told you that's nothing but equal to x when x is said to be greater than or equal to 0, and it is equal to minus x when x is said to be less than 0. Now according to this definition, if I take this, what will I get? Your mod of x plus 2 is equal to plus x plus 2 when your x is greater than or equal to minus 2. Am I right? You will write it as x plus 2 greater than or equal to 0. So when I write it as x plus 2 greater than or equal to 0, how can I write here? X greater than or equal to minus 2. Similarly, it is equal to minus of x plus 2 when x is said to be less than 0. So how do I write that as x is less than minus 2? I hope you understood this. If you want, I'll just write for one here. X plus 2 greater than or equal to 0. Taking it to the other side, you will write it as x greater than or equal to minus 2. This is how you write generally here. So what is the break point you have here? It's minus 2. That is for x greater than minus 2 and for x less than minus 2 only you have two values or two integrands in this case. So here I am going to make use of this property here. Integral over a to b is equal to f of x dx is equal to integral over a to c f of x dx plus integral over c to b f of x dx. What is your c in this case? Okay, if you want, I'll just draw a real line here. When I draw a real line, I have the lower limit as minus 5, the upper limit is nothing but 5 here. In between, what is your c in this case? It's nothing but minus 2. So when it is x less than minus 2, what will be your limit here? Minus 5 to minus 2. Always the lower limit, whatever you write, it must be lesser than the upper limit. So don't write it as minus 2 to minus 5. So what is the first one you have? Minus 5 to minus 2. So when minus 5 to minus 2, what is it? It's x less than minus 2. So for x less than minus 2, what is it actually here? It is equal to minus of x plus 2 you get. So I have written it as minus of x plus 2 dx plus integral of, in this case what have you got? Minus 2 to 5. So minus 2 to 5 means what is it? It is x greater than minus 2. So for x greater than minus 2, what is your thing? It's equal to x plus 2. So I can write the function as x plus 2 dx. Now it's easy for me to integrate it. It's only integration. So one more thing, when you have absolute value, please don't keep it integrating it, don't integrate it keeping it as it is. Okay. So here minus 5 to minus 2, when I multiply it, I'll have it as minus x minus 2 dx plus integral over minus 2 to 5 x plus 2 dx. So here it's minus x squared by 2 minus 2x over the limit minus 5 to minus 2 plus, what is the next one you get? X squared by 2 plus 2x over the limit minus 2 to 5. So substitute the upper limit there. When I substitute the upper limit, minus 2 the whole squared is what? Plus 4. But you have a minus sign here. So it's minus 4 by 2. Minus 2 into minus 2 will give me what? Plus 4 minus the lower limit. Okay. So when it's minus the lower limit, already you have a minus sign here. Minus minus, it becomes plus. Minus 5 the whole squared is what? 25 by 2. Got it? Now again minus the lower limit. So when I put minus the lower limit, already you have a minus sign here. Minus into minus is nothing but plus. Along with that, 2 into minus 5. What is 2 into minus 5? That's nothing but minus 10. Okay. Plus, what will I get here? 5 squared is 25 by 2. Here if you see, it is 10 minus the lower limit, minus, it is minus 2 the whole squared will give me what? Minus 4 by 2 minus the lower limit. So when I put 2 into minus 2, you will get it as minus 4. Along with that, if it's minus the lower limit, what will I get? Minus of minus will be nothing but equal to plus. So I will have it as plus 4. You understood? Okay. So here we'll see what you get. Minus, okay, so here in this case, it's minus 4 by 2 is what? Minus 2. Here again you will have it as minus 2. Minus 2 is what? Minus 4. So this minus 4 and this plus 4, it gets cancelled. Minus 10 and plus 10 also gets cancelled actually here. So you're left, that's what I have written here, minus 4 plus 4. 25 by 2 plus 25 by 2 is nothing but 25. You're left only with 1 plus 4 here. So what's the answer you get here? It is equal to 29. Okay, so it's an important question actually here. Integrating the absolute value actually here, they can give you only one absolute value or sum of 2 or 3 absolute values also can be given. So it's an important question, okay, under this integration, definite integrals. Okay. Now here there's the sixth one here. So what is the sixth one you get here? Integral over 2 to 8 modulus of x minus 5 dx. So again you have the same thing we are going to use here. What will I get here? Your mod of x minus 5. What is it? It is equal to plus x minus 5 when your x is greater than or equal to 5, and it is equal to minus of x minus 5 when x is said to be less than 5. I hope you understood how you have got this. Okay, I'm just using this absolute value just like the previous one only, what I told you there. So we'll just write, okay, if you want I'll just draw a real line here. So what is the lower limit you get here? 2. What's the upper limit you get here? 8. What is the break you have here? It's nothing but 5. So what is that I can have here? 2 to 5 plus 5 to 8. So if it is 2 to 5, it is x less than 5. It's 5 to 8, it's nothing but x greater than 5. Okay. So here that's what I have written here. I is equal to 2 to 5. What is that you get here? 2 to 5 is nothing but x less than 5. For x less than 5, what will you get? Minus of x minus 5 dx plus x greater than 5. What will I get here? 5 to 8 x minus 5 dx. Okay. So we have it as integral over 2 to 5. When I multiply by the minus sign here, you will have it as minus x plus 5 dx plus integral over 5 to 8 x minus 5 dx. So integrate it. Minus x squared by 2 plus 5x over the limit 2 to 5 plus x squared by 2 minus 5x over the limit 5 to 8. This is what you have here. Now this is equal to the upper limit, it's minus 25 by 2 plus 5 into 5 is nothing but 25 minus the lower limit. So minus the lower limit, minus of minus will be what? Plus 4 by 2. Here it's minus the lower limit. So plus into minus is nothing but minus 5 into 2, it is 10 plus upper limit is what? 8 squared. What is 8 squared? 64 by 2 minus 5 into 8 is nothing but 40. Now minus the lower limit. So what is minus the lower limit here? Minus 5 squared is what? 25 by 2 you get here. Minus the lower limit. So minus of minus will give me what actually here? Plus 25. This is what you have here. Okay, so here minus 25 by 2 minus 25 by 2 will give me what? Minus 25 you get there. Okay, so 1 minus 25 and this plus 25, it gets cancelled. Now come to the next one. Okay, so you're left only with what actually here? Okay, you're left with plus 25 is what you have in this case. So you're left with plus 25 in this case actually here. Okay, now here 4 by 2 is nothing but 2. Okay, sorry, 1 second. Yeah, so here you have it as minus 10 minus 40 is what? Minus 50. Minus 50 plus 25 is what? It is equal to minus 25 you get here. That's what I have written here, minus 25. Now coming over to this one here, 2 plus 32. So what is? You will get it as 34. 34 minus 25 is nothing but equal to 9. This is the answer you get for the 6th one. Got it? Yes. Now you are coming over to the 7th one. It's integral over 0 to 1 x into 1 minus x the whole power n dx. Now you just see this. Can you do it by substitution? No, not at all actually here. So if you want to do it by substitution actually here, what will happen? You will have to write it as 1 minus x is equal to t, etc. Again, it will be the roundabout the same thing here. So here what property I am going to use here? The definite integral property. What is the property? Integral over 0 to a f of x dx is equal to integral over 0 to a. It's nothing but f of a minus x dx. This is the property I am going to use here. So by using this property, I is equal to integral over 0 to 1 x into 1 minus x the whole power n dx. Again I have written the property here. What happens to your x here? Your x is replaced by 1 minus x. That's the upper limit minus x. So how can I write here? It's integral over 0 to 1. Your x is replaced by 1 minus x into 1 minus of 1 minus x the whole power n. Don't forget to put the bracket correctly here. The bracket is not only for this 1 minus x, it's a whole thing, the whole power n. So what happens here? 1 and this minus 1 gets cancelled. Minus into minus will give me what here? Plus x power n. That's what I have written in the next step. Integral over 0 to 1 minus x into x power n dx. Now it's easy for me to integrate it. I can just multiply it here. It's x power n minus x into x power n is what? X power n plus 1 dx. So you integrate it. What will you get when you integrate it? X power n plus 1 divided by n plus 1 minus x power n plus 2 divided by n plus 2 over the limit 0 to 1. So you apply the upper limit. What will I get? 1 by n plus 1 minus 1 by n plus 2 by minus the lower limit will give me nothing but 0. Okay, that's one convenience you have actually here. If you have the lower limit, mostly it will be 0 unless and until you have an exponential or something like that. You will have to be a little careful. Now you take the LCM here. When you take the LCM, what will you get? N plus 1 into n plus 2. Cross multiplying it, you will have it as n plus 2. Here when you cross multiply, I'll have to multiply by the minus sign also. So you will have it as minus n minus 1. This gets cancelled. 2 minus 1 is what? 1 divided by n plus 1 into n plus 2. This is what you have here. Okay. Now the 8th question, another important one. Integral over 0 to pi by 4 log of 1 plus tan x. Do you have any formula for log of 1 plus tan x? No. I cannot do it by parts also in this case because it's log of 1 plus tan x. So again I'm going to make use of which property here actually here. It's nothing but the same property. Integral over 0 to a f of x dx is equal to integral over 0 to a. It's nothing but f of a minus x dx. So we are going to make use of this property. So as I mentioned in the beginning itself, mostly I will be using the 5th property very often. Okay. So using that property, your x will be replaced by what? The upper limit. Okay, so upper limit minus x. That's how I'm going to replace it. So how do I write here? Integral over 0 to 4 pi by 4 log of 1 plus tan of pi by 4 minus x dx. And now here it is tan of a minus b. Under this inverse trigonometric functions, okay, you would have learned this. What is tan of a minus b equal to? It is equal to tan a minus tan b divided by 1 plus tan a tan b. This is the formula you have here, 1 plus tan a tan b. So using that, I can write it as integral over 0 to pi by 4 log of 1 plus tan a minus tan b. So what is tan a minus tan b? It's nothing but tan pi by 4 minus x, because this is your A and this is your B, minus tan x divided by 1 plus tan pi by 4 into tan x dx. So here this is equal to integral over 0 to pi by 4 log of 1 plus, what is tan pi by 4? It's nothing but 1 minus tan x divided by 1 plus tan pi by 4 is what? 1 into tan x dx. This is what you have here. Is it clear? Okay. Now your I is equal to integral over 0 to pi by 4 log of, just cross multiply it, you will have it as 1 plus tan x plus 1 minus tan x divided by 1 plus tan x. What happens here? Your tan and this minus tan, it gets cancelled. So you are left with integral over 0 to pi by 4 log of 1 plus 1 is what? 2 by 1 plus tan x. Okay. Again, it's not possible for me to integrate it. Neither have I got it in the question form also. So see what I can do here. I'm going to make use of this logarithmic rule. Log of m by n. What is your log of m by n equal to? It's nothing but equal to log m minus log n. This is a rule we have here. So using that, I can write it as integral over 0 to pi by 4. It's log 2 minus log of 1 plus tan x dx. This is what you get here. So this is equal to integral over 0 to pi by 4. It's log 2 here dx. I've just split it as two separate integrals, minus integral over 0 to pi by 4 log of 1 plus tan x dx. This is what you get here. Okay. Now what happens to this one here? It's nothing but minus I you have here. Integral over 0 to pi by 4 log 2 dx minus I. Okay. So here you have got it as I. Why I write it as I? It's nothing but your question itself. So you have it as I. Now take this I to the left hand side. You will get it as I plus I is equal to 2I, which is equal to, this log 2 is nothing but a constant. So I can take it outside the integral and write it as log 2 into integral over 0 to pi by 4 dx. So what will I get? Log 2 into integral of dx is what? X over the limit 0 to pi by 4 you get here. So here when I substitute the limit, what will I get? Upper limit is nothing but pi by 4 minus the lower limit is nothing but 0. So I have it as pi by 4 into log 2. So what is your I equal to here? I is equal to pi by 8 into log 2. Is it clear to all of you? Yes. Okay, the ninth question. I is equal to integral over 0 to 2 x into root of 2 minus x dx. Again, looking at this, what is it? By substitution, neither by parts, nothing. So what's again property I use here? Integral over 0 to a f of x dx is equal to integral over 0 to a, it's nothing but f of a minus x dx. This is a formula we have here. So integral here in this case, your x is replaced by what? The upper limit. What is the upper limit you get here? 2 minus x. This is how I am going to replace it here. So I write it as 2 minus x here. Square root of 2 minus of, this is written as 2 minus x. Be careful with the minus sign here. Don't just write it as minus 2 minus x here. You will not get the answer. Okay. So here it is integral over 0 to 2 minus x. Your 2 and minus 2 gets cancelled. Minus into minus, what will I get here? It's plus root of x dx. This is what you have here. Now multiply it. Integral over 0 to 2 root x minus x root x dx you have here. So this is equal to integral over 0 to 2 root x minus x root x. What is this x into root x? It's nothing but x power 3 by 2. So now integrate it. So when you integrate it, what will I have? 2x power 3 by 2 divided by 3 by 2 minus x power 5 by 2 divided by 5 by 2. What's the formula? Integral over x power n dx is equal to x power n plus 1 divided by n plus 1. This is a formula we have here. Okay. Apply the upper limit here. So when I take this to the numerator, it is 4 into 2 power 3 by 2 divided by 3 minus, this goes to the numerator, 2 into 2 power 5 by 2 divided by 5 you get here. Now this 2 power 3 by 2, I can write it as 2 into root 2. Can I write it like that? It's nothing but 2 into root 2. So I write it as 2 into root 2. 2 power 5 by 2 can be written as what? 2 power 5 by 2 can be written as 2 power 3 by 2 into 2 I can write, because this is nothing but 1. 3 by 2 plus 1 only is 5 by 2. So how do I write this as 2 root 2 into 2? So it's nothing but equal to 4 root 2. So I have written it as 4 into 2 root, sorry, this one here I have written it as 2 into 4 root 2 I have written here divided by 5. Got it? So here also you have got it as 8 root 2. Here also you have got it as 8 root 2. Taking it outside, it's 8 root 2 into 1 by 3 minus 1 by 5. What is 1 by 3 minus 1 by 5? It's nothing but 2 by 15. When you take the LCM and simplify it, 8 into 2 is nothing but 16 root 2 divided by 15. This is what you have here. Got it? Yes. Now the 10th question here, integral over 0 to pi by 2, 2 into log of sin x minus log of sin 2x dx. Got it? Yes. Now here I have a problem. What's the problem I have here? I have 2 here. Here I have sin 2x. These are the problems where I cannot apply this property directly here. Integral over 0 to a f of x dx is equal to integral over 0 to a f of a minus x dx. Not that because they are there I cannot apply here. Even if I apply, I will not be able to simplify. That's the reason here. Okay. Now here this 2 you have 2 log sin x. So there I am going to use this rule here. Log of m power n. What is log of m power n equal to here? It is equal to n log m. So how do I write here? N log m can be written as log of m power n. So what is your n here? 2. So I can write it as log of sin x the whole squared. So that's nothing but log sin squared x minus log of sin 2x dx. Got it? Now here what property you're going to use now? Log of m minus log of n. What is it equal to here? It's nothing but log of m by log m by n. That's the property we have here. So I have it as integral over 0 to pi by 2 log into mod of sin squared x by sin 2x dx you have here. Got it? Yes. Now it's easy here. It's integral over 0 to pi by 2 log of mod sin squared x divided by sin 2x can be written as 2 sin x cos x. So here if you see it gets cancelled actually here. So you're left with only sin x by cos x. What is sin x by cos x? It's nothing but tan x divided by 2 dx. Okay. So again keeping it as it is, I cannot integrate it. So what's a property? Again I use here this logarithmic rule. I just split and write it as integral over 0 to pi by 2 log of tan x dx minus integral over 0 to pi by 2 log 2 dx. Is it clear? Okay. So here this is what we have here. Now come to the next one here. I am going to apply. So here when I integrate this one, of course I'll have to integrate it by the property here. So keeping it as it is, integral over 0 to pi by 2, it is log of tan x dx is what you get here. When I apply the upper limit, what will I get here? It's just pi by 2 into log 2. I'll just mark this as 1 here. Okay. So we'll just mark. How do I get it as pi by 2? Pi by 2 minus the lower limit will be nothing but 0. So you have it as pi by 2 into log 2. So I'll just mark it as 1 here. Now I'm going to use the property here. What's the property? I told you in the beginning itself, no? Integral over 0 to a f of x dx is equal to integral over 0 to a f of a minus x. I'm going to make use of that property there. Okay. So here your I is equal to integral over 0 to pi by 2 log of tan of pi by 2 minus x minus pi by 2 log 2. This one I am not going to touch at all because I have already integrated. So that is left as it is here. So what is tan of pi by 2 minus x? That's nothing but equal to cot x. Again you know that all silver teacups, the same thing I am using here. So I is equal to integral over 0 to pi by 2. I can write it as log of cot x minus pi by 2 into log 2. This is what you have here. Got it? Now what's the next one you get here? I'll mark this as 2. Now I'm going to add 1 and 2. So when I add 1 and 2, if you want, just for your sake, I'll just write what is my 1 here. What is your 1 here? Integral over 0 to pi by 2. It's log of tan x minus pi by 2 log 2. This is your 1. So we'll just add 1 and 2 here. When I add 1 and 2, it's I plus I will give me 2i, which is equal to integral over 0 to pi by 2. Both have got the same limits here. So I can write it as log tan x plus log cot x dx minus, I'm going to add these two, minus pi by 2 log 2 minus pi by 2 log 2. Got it? Now here, this one, what's the formula you have actually here? Your log of mn. What is log of mn here? It's nothing but equal to log m plus log n. This is the formula you have here. Okay, log m plus log n. So using this formula, I can write it as integral over 0 to pi by 2. It is log of tan x into cot x dx minus pi by 2 minus pi by 2. What is minus pi by 2 minus pi by 2 will give me what? Minus pi log 2 is what you have here. Okay, because here again it gets cancelled, you'll have it as minus pi log 2. Now what is this cot actually here? I can write, if it is tan x into cot x means I can write it as 1 by tan x. So it gets cancelled here. So finally you'll be left with log 1. Integral over 0 to pi by 2, it's nothing but log 1 you will have. What is your log 1 here? It's nothing but 0. So integrating 0, you will just get it as 0. This is after integration only. As I have it as minus pi log 2, I actually have it as 2I equal to. So what's your I equal to here? Your I is equal to minus pi by 2 log 2. Is it clear? Yes.